First one over there. I'm going to talk about application. Okay, this is work I did on developers and LSAs and providing tools. And the method is to have it done by, with my guess, here's some body you can hear
large corpus, you might have, say, a vocabulary of, say, 100 to 200,000 words. A paragraph will have no more than, say, 100 or so. Go through the algebra here, you see that the word that appears in every document will essentially have and you can range them from highest to lowest. It is also used, and this is, again, as I said, this is the patents essentially that Pearson bought back in 2004. It was a big announcement. That actually, that application was developed at the University of Colorado. Another application is intelligent tutors. You can imagine an intelligent tutor getting text input from students and deciding what is the best material that the students needs now. There are things like summarization, reading comprehension. The teacher, the automatic tutor can now tell the student which parts of the text, which concepts it missed, and so on. And one of the most recent applications, and one I will talk about, is concept inventories. And we'll talk about concept inventories, what they are. It identifies student essays that express particular concepts, and that helps us in developing the concept inventories. And it can also identify new concept clusters. A sub-application of this is we have looked at dimensionality of discourse. So the idea is if now your concept map has a lot of, students' concept maps have a lot of, let's say, misconceptions, and one of the questions, natural questions to ask is, well, how much of the conceptual space of the student is now taken up by these misconceptions? And the first thing we need to do to find out, measure, is find out dimensionality. And that's why we look at dimensionality of discourse. So what are concept inventories? Concept inventories are multiple choice instruments. The usual, they look like an ordinary text. But they are very different from ordinary tests because the distractors, that means the wrong questions, are researched as meticulously as the correct answers, in fact, more meticulously than the correct answers. And each one of those represents a known misconception. So the idea is that the student presented with a question from a concept inventory, and the answers will see in the answers the misconception that they hold. And it uses students' natural language, and this is important, that's where LSA is being used to find for us that natural language, because we don't want students are well known to use, yes, go ahead.
Okay, so what is misconception and how do you measure it?
Okay. So misconceptions are deeply held models that people have about how the world works. Especially in the sciences, you cannot, it's the old Aristotelian idea, you cannot not make a model. Presented with the world, people make models in their head about how the world works. And these are usually wrong. And they persist, these misconceptions persist after repeated instruction. There are, I don't know how many of you have seen The Private Universe? That's a pretty old movie by now. So they videotaped, they went to the Harvard graduation and asked students who were graduating to explain the reason for the seasons. And invariably, people said that in the summer, the Earth is close to the sun, and in the winter, the Earth is farther away from the sun. And of course, they had more, they videotaped classes in which explicit instruction was given about what the reasonable decisions are. At the end of the semester, they go videotape the students. The summer is because the Earth is close to the sun, winter is because far away. These are fundamental models that people have in their head about how the universe works. And even after repeated instruction, if you press them, they will always revert back to the model they have. And they are obviously the greatest barrier to STEM education. And they require consistent, not linearly independent, let's say, instruction that explicitly addresses them. There are a lot of methods that have been developed, a lot of curricula that have been developed in the sciences to address these misconceptions explicitly. But before you address them, you have to know what they are. And these concept inventories are the way we go about.
But do you really think it's the greatest barrier to STEM education?
I'm sorry?
Maybe a reason to say that it's the greatest barrier to STEM education, but I would think that in math, as well as in some technology and engineering, the barriers that people have trouble relating abstract formulas to real-world concepts, or they can't do proofs or something like that. I can believe this is the greatest barrier in science. Is it really in the other areas?
So I'll talk about this. There are a lot of, so it depends on what you mean by misconceptions, and we'll talk about, for instance, the biology concept inventory, and how we found that a lot of misconceptions are a lot of the, let's not call them misconceptions, a lot of the trouble people had in doing this precise reasoning that you're talking about precise reasoning, stem from misunderstandings they have about the fundamental concepts of what's going on. For instance, here, you ask them, how do molecules come apart? They usually will say things like, you need some other chemical interaction. The fundamental misconception that we found is they do not understand that there are random processes that are going on all the time, whether something is, a molecule is associated or dissociated or not. So a lot of that, there are problems with mechanics, problems with precise reasoning that you mentioned, that are more prevalent, I guess, in engineering terms.
Maybe, and I'm just sort of curious, like my model of why it is that somebody has trouble with conic sections is not that they have some other idea about conic sections that's getting in the way. But maybe that is what's going on.
Possibly.
Yeah.
Unless we go and look at their ideas of conic sections, we don't. And there are, if you go into details of for instance, how exactly students talk about chemical reactions, you can get into technical issues that you may think are dominant. But if you push the reasoning, you find out that essentially, for instance, chemical reactions, and there's another question in the biology concept inventory, chemical reactions, people think that the chemical reaction is a key and keyhole issue. So two molecules fit exactly together. Now that allows no room for evolution. You cannot evolve a molecule if it either fits or it doesn't fit. They do not understand that it has to do with energy minimization, and small variations in the shape of the molecule can change the energy minimization, and you can have a continuous change from one molecule to a different molecule. And all of these molecules are present in the solution all the time, and they dissociate and associate continuously dynamically. So there may be some detailed technical issues about accurate reasoning, but the fundamental concepts are usually the major barrier.
I guess you're saying unless you can visualize the problem properly, you are not able to write the math.
Yes.
To solve it.
You have the wrong model in your head, and the minute you're pressed, either by an instructor or by a test, you revert back to the model that you understand. So the impetus for this was the force concept inventory we developed actually back in much earlier than 1888 or so. It has 30 multiple choice questions. It probes understanding about 1/3 of the introductory physics course. And it enabled repeatable measurements of people's understanding, and that's where people realize that even after repeated instruction, students still held to their own misconceptions. There's an anecdote with Eric Mazur. When he first saw Kate give a talk about the concept, the force concept inventory, and how these misconceptions were persistent. He says, I thought immediately, no, my students, maybe your students. So, but when he tried it at Harvard, he saw that yes, even after an entire semester of physics instruction, the students made the same mistakes. Classic mistakes like if you throw a ball in the air, what are the forces that act on the ball when it's at the top of its trajectory? Some people say your hand is the exerting force. People say there is no force because it's stopped. So there are, classic misconceptions. Ever since the force concept inventory was developed, there is an entire industry that produces these things. There's thermodynamics, fluid mechanics. Interestingly, there are a lot of concept inventories for computer science. I found very few about electrical engineering. So if any of you have any students that are interested in developing concept inventory, there's an opening there. The trouble with them.
Find them?
I'm sorry?
Is there a concept inventory directory?
A lot. And yes, there is one for EE. Have I put it there?
Industry codes. So it's not just a directory, it's a whole industry.
It is. So, however, the problem with these instruments is they're very expensive. And they're very expensive because you require, you have to find all the misconceptions and you have to research both the correct answer but also the distractors very thoroughly. And as a result, they are not being used for grading. They're used for educational research, for telling people what materials, instructional materials to develop, but they're not used for grading. And you would like to be able to use them, for instance, use these conceptual questions in your classroom. Now, the cost is driven by validity and reliability. Validity for an instrument means that it's measuring what you think it is measuring, and it's not measuring other things. And reliability means that if you measure the same thing 2 or 3 times, it will give you similar results. Both of those require natural distractors. If your distractors, if the wrong answers are random, they will lure your students into random answers, and that will degrade reliability. If they are obviously wrong, they will degrade validity because you're now suddenly do not have a question with the correct answer and 3 distractors. You have a question with the correct answer and no other option. This is what's called construct irrelevant isms. So knowing the misconceptions and being able to capture them in language that is natural to the students in the distractors is critical. One good statistical test for a well-constructed concept inventory is to find the random floor. If you have a question with, say, 5 answers, one of which is correct, and you give it to people who have never taken the exam, have taken the course, don't know what, never taken physics before, all answers will have a random floor, so it will all be about 20%. For concept inventories, the random floor is often a lot lower than, say, 20%, and often very close to 0. That is because the student that does not know the correct answer sees in the distractors the belief that he has in his head of what the answer should be, and is lured to that as opposed to randomly picking something. So it's a very good statistical test of whether you have a well-constructed inventory or not. Yep.
So it's interesting that on average people have the wrong model. I mean, sometimes we think about crowdsourcing where you say, if you aggregate a lot of people, they'll in general point to the truth. But you're saying on average, I guess it's because you carefully selected the choices to choose among. But I guess you still include the truth and other wrong things, and they on average don't choose the truth. That's kind of interesting.
Yes.
I mean, maybe it's just the problems that you're
so
interested
crowdsourcing
in
is usually a voting exercise. Right? Yeah, you don't go to crowdsourcing to find solve physics problems or solve engineering problems.
Oh, we
and if you do, you might get the experts. And somehow, at some point, you have to separate the expert answers from everybody's misconceptions. This is not unusual, for instance, when you assign exercises to students and they go and look on the web for them. A lot of the answers you get are the misconceptions that people have put on the web. So the way you build those is you ask students to create language. So you ask them open-ended questions, they answer them, you you edit the answers, collect the language, create questions and answers, give it the instrument to students, repeat until you converge. And that's again the process that we're talking about.
So Isidoros, in many ways, so this is kind of a theory of learning. I mean,
absolutely, yes.
I mean, in a sense, it's concept formation and analysis.
That's right. And we have to, yes. The idea is we have to find those concepts that people have. Yes.
So,
yeah.
Has there been any effort to identify how people gain these misconceptions? Because the reason being, right, like if you need to correct them, why not skip the correction part and just do it right in the first place?
So that, yes, and a lot of people have, yes, tried it, gone down in that direction. The question is where and how early do you have to get them? So this is the idea that you have to get them in high school. So the colleges say, oh, you have to get them in high school say you have to get them in elementary school. The idea is again that people cannot avoid making models in their head. So it is not clear at what age you have it. And there are concept inventories, for instance, for elementary school, even early elementary. You ask people about, let me see, a classic misconception is what happens to the moon when there's no moon. A lot of early young kids will say it's covered by clouds. We have some of our own research, not very young kids, but where the rainbow comes from and why it's up in high latitudes. The rainbow is the prismatic breaking up of white light by the ice. That's why it's up north, where the ice is. So it is very difficult. People will always make models in their heads. It is very difficult to know where those models come from.
Well,
there is research on that.
I mean, clearly those models come from our exposition to known physics. The more physics you're familiar, the likely those misconceptions will go away. So.
And this is not just, I'm talking about STEM education. This is things like, we have a lot of research done on collaboration, for instance. People have, so social systems. Yeah. People have very strong misconceptions about collaboration. The classic ones are collaboration is efficient. Another classic one is collaboration means getting along. Another one is collaboration means division of labor. So you can imagine having a group in which some people think that collaboration is efficient, and the other half people think that collaboration means getting along, and they're not going to get along. Because collaboration is not efficient. So yes, people have tried to find out where they come from, but usually we have to fix them afterwards. So, and the way we go about collecting the language is you ask students to create, give you an essay, and then you go and code that essay. And let me go here and read this. So one of the questions was, what's the cosmological constant, and describe its importance in astronomy. It was created by Einstein, and this is the cosmological constant. It's used to have a static universe. A classic misconception is Hubble. All galaxies are moving away from one another due to gravity pushing. So God only knows where that misconception came from. The gravity is actually pushing the galaxies away. This has to do, I guess, with negative energy and so forth, so we found somehow students confront negative energy with gravity pushing. This is a classic misconception that we found.
This is college physics?
Yes. Freshmen and sophomore. So you collect all that language. You go with your mouse and collect all this, and then in the end, that's connected to a database. And then in the end, the computer will now aggregate the language. It will give you all the student language, the ways that this grader, me in this case, can tell that this particular student of this concept, that cosmological constant is a repulsive force. And then you take all the language and whittle it down, and you come up with the answer in that question that is supposed to lure the students that have this concept in their head. So once you do this, you do the concept inventory, you give it to the students, you do not then think aloud. So once the students pick that, you want to make sure that the student that picked that answer actually does hold that concept. And this is validation. And once you do that, you create the instrument. I will skip this. So what does LSA have to do with this? A lot of answers are often devoid of any meaning, any science. For instance, we asked students, what happens if a heavy truck collides head-on with a light car going opposite directions with the same velocity? And this answer here has no physics in it. The person that drives the light car will be injured, the car will have more damage, no energy, no momentum, no velocity, no mass. So you would rather not have to spend your time looking over essays like this. In addition, you not only have to grade or grade essentially the essay for correctness, you have to grade along all dimensions. So does it have an energy component? Does it have a momentum component? Is the correct energy, is the wrong energy? So this increases dimensionality of the problem enormously, and you have what we call a recursive dimensionality. You need to do, say, I don't know if you're familiar with test theories, the atom characteristic curve. It tells you that if a student of ability theta is given a question of difficulty theta, then 50% of the students will answer the question correctly. So you have to do that not only for the items or the correct answer, but for each of the 4 or 5 distractors. So that essentially explodes the dimensionality 5 times, or maybe more. So the idea is we would like somehow to automate this and be presented with the documents that we know have the concepts that we're looking for. And that's why I say looking for truffles. There's a joke in physics about the relationship between theoretical and experimental physicists. They say that's the relationship, the same as the relationship between a truffle hunter and his dogs. The truffle hunter takes his dogs to the forest, the dogs do all the work, and when they find the truffle hunter goes and takes the truffle away. And it seemingly breaks down because at least the truffle hunter takes his dogs in forests in which truffles are known to grow. So we'd like to go looking for these concepts in essays in which we know they exist. So we do the same thing as they do for grading essays, but we do it now per concept. So by grading from 0 to 2, we're not grading the correctness of the answer. What we're saying is this concept present in this essay, and is it not present at all? Is it present and correct, or is it touched on but not quite right? And we do this over, say, 100 or a couple hundred essays. And then we look at again, the same as we did for the grading, the inter-rater reliability between expert, and LSA. And we can do this for, we can grade the essays, or LSA can grade the essays based on a general corpus that has just general text in it. I think we used TASA here, where it has about 40,000. It's a standard corpus. Or you can augment the corpus with text from the domain, so physics, biology, chemistry, and so on. If you augment the text with the domain, you get a slightly better correlation, expert LSA, than if you do just general corpus. So that can significantly improve the time it takes for us to develop a concept inventory. The biology concept inventory, for instance, has 30 questions. Sorry, this is not 30 essay questions. It's 30 questions in the actual inventory. We collected more than 10,000 student essays. There are 50 plus coding dimensions. If you had to do this just by hand without LSA, it would take like 2 or 3 times as long. And the initial ones, for instance, the FCI took 10 years to develop. The ADT, the astronomy diagnostic test, about 3 or 4 years. The BCI, we completed 30 questions in about 3 years or so. So the experts code a small number, and then LSA provides reliable statistics for the entire 10,000 essay body. Now, the next step for automating this would be to not only tell us where the concepts are, but actually find misconceptions that we did not know were there. This is slightly harder. However, we have used you can take the student essays, use something like K-means or whatever other clustering software you want, find clusters, and then the experts can go in and label those clusters. Now, you can test this, of course, in text. So test it in physics texts, in astronomy texts. And then you can say, well, is this clustering technique going to give me the chapters of the text? And that would be some kind of validation that the method is working fine. For physics, it will give us the correlation between the clusters and the chapters in the books. About 83%. Astronomy is not as good as 167. Once you do that, you can now try and cluster the concepts and see whether you can find misconceptions that were not there, or concepts that are expressed by the students that you don't know about. And for that car truck question, K means you're required to give how many concepts you want. If you give a correct number, you give an 85%. If you don't, you don't do so. So we can use Latent semantic analysis to improve essentially the speed with which, or the economics of developing concept inventories. Concept inventories are very important for science education. We can not only improve the economics, but also use different metrics for those inventories. And that's it. Thanks very much.
So is there a tool, Isidoros, that is there a public domain tool or open source tool to do this?
To do what?
To do latest semantic analysis. I mean, can I go and get it? Can someone go and play with this?
Yes, lsa.colorado.edu has a bunch of tools that you can play. They're kind of older by now, but yes, definitely. Yes.
Has anyone tried this on, I don't know, like blogs and things like that to see what kind of misconceptions exist out there in the public about other things?
Yes. In fact, there was one recently. done in France about, I don't remember now what it was about, but they analyzed things like 150,000 blogging profiles. Obviously, political opinion would be useful.
Yeah.
Yeah. Yes, no.
No, but I'm also thinking about, like, misconceptions about public health. Like,
Yeah,
whether
public health,
something is safe, unsafe, whether some treatment works, doesn't work, prevention.
You would think, but no, I'm not aware of it. Things like public policy,
Yeah.
public health, no. Not aware of. Yep.
So this is a new area for me. I'm just curious, so at the end of the day, understanding or misconception is really just identified by the presence or absence of a collection of keywords. Is that correct? That appear together, that are clustered together. There's no consideration of order of the words.
Well, okay. So this is okay. I'm glad you asked the question. This is one of the classic differences between, let's say, it's a bag of words. The Earth is going around the Sun is going around the Earth, are the same thing as far as LSA is concerned. So for short answers of a sentence or so, you cannot use LSA. That is well known. So we have looked at how long does the answer have to be before you start losing it. About 50 words is about the limit. So if you ask people, and that's why we ask people to produce, say, about 100-word essays. If you ask people to expand, so you ask person, is the sun going around the Earth or not? And it says the sun is going around the Earth, or the Earth is going around the sun. If you leave it there, they may be able to get away with having misconception. If you ask them to produce an essay about this, essentially you cannot fake it. You cannot fake it for more than 100 words. Your fundamental model of how things work will show up. Because it is not just certain keywords. It is all the ratio of all the words that you use to the ratios of all the other words that you did not use. It is very difficult to fake it for 100 words.
So, Isidoros,
Yeah.
but it looks to me like you're more looking into the depth of the understanding than the concept, because the Earth and the Moon, they go around. The Earth and the Moon go around is correct. It's a concept.
The concept is there. Yes.
So it is. So what goes around?
Yeah.
One or the other, then you have the sun, and they all go around, okay, so the sun doesn't go around, So I guess in many ways it seems like it is really testing the depth of your understanding than just a basic understanding.
And again, LSA just creates a vector space, right? How you use that vector space, so how, for instance, you classify now this vector that you have among the misconceptions or the concepts, is a totally different thing.
It's kind of interesting that you don't try to do meaning of a sentence to summarize meaning of a paragraph, but you kind of use kind of a very, very just mathematics to just get your answers.
That's right. You do not. So there are methods. Semantic parsing, for instance,
yes.
will parse things. Will parse. There are things that will try to find the action, the actor,
yes.
the object, and so forth. It is surprising that LSA is so good just by being a bag of words. I guess that does have to do with the fact that people cannot fake their language for long. There are very few very well-trained actors that can be in character for a long time. Yes?
So, I'm not sold on this being actually useful for education, particularly if you're using it to create evaluation. This might be because I came from a bombardment of standardized tests, and I consider them a whole waste of my time because, it's obvious. You're asking me this question because you want me to pick that answer, right? I'm not. I was doing nothing along the lines of trying to. So, from my experience, which is of course not necessarily valid, like as a whole, I would take the tests not like using any sort of background, not really like this, not really just answering questions. I would take the test answering tests, right? Like you. So
that's
right,
a difference. That's exactly the difference between a test and a concept inventory. For a concept inventory, you cannot do that. You will see the thing that if you take a concept inventory on something that you know well and the answers that you know are correct, they're fine. But if you take a concept inventory, a well-constructed concept inventory on a subject on which you have misconceptions, you will see in the answer, bright and clear, exactly what you think. And you will see the answer say, of course, I always knew that this is right. And that's why you're going to do it. And that's why the random floor for the wrong answer, for the correct answer, is not 20%.
So, what you're really saying is that in a good multiple choice test, even when I get the wrong answer, I will be very confident that I got it right.
Yes. You
And
know
that is how
this,
my
yes.
deficiencies will be revealed.
Because it captures your belief.
So basically, that's the charge or the challenge to the designers of the multiple choice.
So
Yes.
So given what you just said, Sanjeev,
Yeah.
let me. Are you done? Sorry.
Yeah.
No, I have a follow-up question to that. So does personality and furthermore gender has an impact on actually how you perform? Because
I'm not aware of any gender studies. This is a very interesting question, and there should be a study.
Yeah, no, I didn't mean confidence in the sense of like, my self-confidence. I just meant in terms of it gels with my concept of how the world works.
But it may also be that you think you know the all, but you really don't. I mean.
So for the BCI, we had some of the early tests included your self-confidence. So you pick the answer, and then there's also a little box that says how confident are you that this is the correct answer. We did not find that did anything. Once the questions are well constructed, once the wrong answers are well constructed, how confident you are doesn't matter. You will pick what you think. And so what you were talking about is these curves here, the item characteristic curves. Usually for a test, you only do these for the correct answer. Is the person that answered the correct answer, do they actually believe that this is the correct answer? If you do this for all the answers, then you now have a concept inventory. But that's why it's so expensive. It's 5 times as much. Yes.
Curious how this relates to other natural language processing problems. Like a lot of people have probably seen like IBM's Watson competing on Jeopardy and just blowing everyone out of the water. Is that using a similar approach?
So there have been these are the other non-education applications for LSA. So LSA has been shown to the same way that it can mimic grades, it can also mimic, say, word association. LSA, if you ask LSA to associate words, it associates them about as well as humans. I don't have those statistics on my fingers because that's not the work that I can do. But yes, a lot of things like word association, free word association.
Okay, so I think let's thank the speaker because some people may have to go. And if anybody wants to go lunch with Isidoros, any of the students, please just show up here. Otherwise, all my students are going to go lunch with me. So just if you want to block my students, come and have lunch. Please do.